ever wondered how the solar system formed? Maybe you know that large bodies form from collapsing gas clouds out in space. This is true, but it's not the full picture. When those large clouds collapse, they end up with a ring of gas and dust around the early star that we call a planetary nebula, or gas disk. In this gas disk, little clumps of dust will stick together, being very boring, until they reach a large enough size. When that happens, they can start to exhibit gravitational focusing. Gravitational focusing can be thought of as how much that amount of mass will pull other mass into it. Described by this formula, which is dependent itself on the escape velocity of the mass in question, and v infinity, the average speed of the surrounding dust particles. Used in finding dm/dt, the rate of mass accretion with respect to time, we can model it using a sheet, a mass, and some accreting dust particles, in this case, little tennis balls.
When one doesn't include the gravitational focusing factor, mass needs to collide physically with our planetesimal in order for it to accrete and grow. Things like rebounding mass that's going too fast, v infinity is too high, that also doesn't accrete. There's no gravity to pull everything into the center. You can also see that when mass is sent around the planet, it doesn't quite accrete. It doesn't get sucked in, again limiting growth. When gravitational focusing is included, is considered, represented here by taking away the support for our planetesimal, its effective radius gets much larger. The mass of the accreting material and the planet itself will suck more and more mass in a process that gets faster and faster as more mass accretes. There will still be particles that make it out, but not nearly as much. It's a much faster process.
Hearing that, you might wonder how this runaway growth might stop. There are two things that slow and eventually stop this growth. One, simply enough, is that there's not an infinite supply of material. Eventually it has to stop, eventually there isn't more to accrete, so runaway growth would stop. The other, more rigorously defined way is that runaway growth stops when the largest bodies are large enough to mess with the other large planetesimals, sending mass elsewhere. This leads to then the oligarchic growth phase, slower than the runaway phase, but still faster than when the body was very small.
So what are you waiting for? Get on out there, go start collapsing gas clouds, and with enough hard work and perseverance, you too can start to focus on the gravitational focusing factor.